Okay, again, this is the mid-chapter 3 practice test, and this is number 8. And the coordinates of a moving object for various values of t are given. A, you have to plot s versus t, plot s versus t, sketch a smooth curve through the given points. So this is a little graph that we gave you, and you have to put these points in at these different values. And you can label this 1, 2, this was, I think, given to you as 2, 3, 4. So you put your units in, and you got your values here, so you just plot the points over the first 4 seconds. And I think you can see how I did that, so I'm not going to take the time to do that. You just have to be careful to plot the points, and you will be graded on the graph also. And then they want you to say, assuming the smooth curve represents the motion of the body, estimate the velocity at t equals 1, t equals 2.5, and t equals 3. So at t equals 1, I'm just going to take the values around 1, the closest values I have, which in this case are 0.5 and 1.5. I'm going to take those values and find the average rate of change over that interval from 0.5 to 1.5. So I just did this over here. So that would be like f of b minus f of a all over b minus a. So that would just be s of 1.5 minus s of 0.5 over 1.5 minus 0.5. So that's, again, like our average rate of change. So there's a lot of this on here, so make sure you're up to that. And when I looked at the table, this was negative 15 minus, and this was also negative 15. So I had negative 15 minus negative 15, which is negative 15, plus 15, which is 0, over 1, so that was 0. Okay, around 2.5, my values, I used S of 3 and S of 2, because those were the values right around 2.5. If you look at your table, all right, S of 3 was 0, and S of 2 was negative 12. So you can check on the table. S of 3 is 0. S of 2 is negative 12. All right, so that was 0 minus negative 12, all over 1, but negative times the negative is positive, so that was just 2 over 1, which is just 12. And then for 3.5, I used S of 4 and S of 3. So this is my 4 and 3, and 4 was 20, and 3 was 0. So that's easy to see, over 4 minus 3. So this should be pretty easy. Over 4 minus 3, and this was 20 minus 0 over 1, so that's 20. They may not have so many zeros in them, so, but you get the idea. So that's not anything that's too terribly difficult. Okay, so that was number 8. Okay, let's take a look at the other side. Number 9. And we have a derivative here, so it looks like we're going to use the quotient rule on this. So let's take a look at this. This is number 9. So y equals 3x plus 4 over 2x minus 1. So y prime equals, so we're going to take low d high, less high d low, denominator squared below. So the low is 2x minus 1. D high, and the derivative of this top is going to be what? 3. Less high, that's going to be the 3x plus 4, times the derivative of the bottom, d low, which is just 2. All over the denominator squared below, which is just 2x minus 1 squared. And then you'd have to simplify, and then we'll probably have to give you some possible answers so you can choose the one that's correct. So you may have some choices here, so we'll get it in the right form, so y prime. But I can simplify this. 3 times 2 would be 6x, negative 3, and that's going to be, if I could put this 2 in front, like this, negative 2 times 3 is 6x, and negative 8. Negative 2 times 4 is negative 8. All over that. And 6x minus 6x cancels, and negative 3 and negative 8 is negative 11. So I got negative 11 all over 2x minus 1 squared. And that's about what you're going to do. You don't have to, that's all you can do. You don't have to simplify it. Okay? And number 10. Okay, find out values for which the function f of x equals x minus 4 over x squared minus x minus 12 is differentiable. Well, if we look at this function f of x, this is number 10, f of x equals x minus 4, and I can factor the bottom, so I can look for any vertical asymptotes, and I've got x and x. And the signs are different, negative, positive, and it's going to be, to give 12 different by 1, so it'll be 4 and 3. So this is what I have. Now, even though I can cancel this out, I would have a removable discontinuity at 4. So at x equals 4, I've got a removable discontinuity. And at x equals -3, that makes this part 0. What do I have? I have an infinite discontinuity, or an asymptote. So in each case, I've got discontinuities. Every other place that we don't have any issues. We've got a nice smooth curve. So it's differentiable for all x and you could say comma except x equals 4, comma x equals -3. Or you can just say x cannot equal 4 and x cannot equal -3. Either way, for all x except these values. And this would probably be a little bit better. For all x, let's cross this out. Because we're asking you, where is it differentiable? It's differentiable for all x, all values of x except x equals 4 and x equals -3, because at 4 I have a removable discontinuity. All right, and at -3 I have an infinite discontinuity. All right, so I hope that makes sense. So make sure you review all those little situations.